Our next speakers is Professor 张明。张明他是我非常好的朋友，他其实今天还有其他的 schedule， 那他特地从香港过来，因为我这次讲说我办这个研讨会，其实很多人为我两肋插刀，他也是其中一个，被我插了2刀才过来帮我忙，因为这个很感谢研讨会。So Professor Chen is one of my best friends. He has done so many years in footwear biomechanics. 张明教授他是北京科大毕业，然后到英国拿到英国这个 King's College 就London University， 在这个复健工程这个生物力学方面。我本来不晓得他在复健工程领域已经做那么多年了。我上个月去北京的时候才知道，几乎每个人都认识他。Actually, everybody knows him. Okay, because he's quite famous. Okay, in the rehabilitation area and biomechanics. Okay, 所以我就不耽误时间了。所以我们欢迎张明教授给我们演讲。
Okay, thanks, Professor Yang. Thanks for your invitation and nice introduction. Also, thank you and your team put a lot of effort to make this conference now ready. Okay. And actually, this is my first time to talk in this convention center. And when this time Professor Yang invited me to talk, I think I should give something different from previous presentation. I think most of you know my team mainly work on computational model. And I don't know how many of you listened my presentation before. And I apologize to say I have to repeat some of them, but I will guarantee to give you some new information. Okay, that's why I choose a topic called initial biomechanical environment of food. So I'm very glad to see there are so many young students also do very similar project with us. So I come from the Hong Kong Polytechnic University. So we have a research center called Research Center for Musculoskeletal Bioengineering. And we have about 13 or 15 academic staff working in the area related to musculoskeletal bioengineering. What I want to talk today may be a little bit about human foot and ankle, foot support design, consideration and criteria, and talk some experiment on foot environment, some computational modeling. I think all we understand foot is a very complicated structure with so many bones, joints, ligaments, and muscles. And the function of foot should be provide stable support, surface adaptation, shock absorption, and energy storing. And the foot have a very good structure with a 3 arch, which provide a very good load carrying. And as we know that they are very much like the spring system, has stored energy and release energy, push working fast. And also, foot have very good structure. If you turn in one direction, becomes stiffer. In the other direction, then become soft. And to adapt different surface. And when we talk about the function of shoes, the shoe should provide a comfort environment for foot and protect the foot from injury, enable the foot to function as support and locomotion in varied surface conditions for different activities. And that's why I choose the topic, say, the initial biomechanical environment. There are a lot of the problems, and we are intend to solve those problems by surgical treatment or external support. I think many of us sit here to talk about how to using special insole or foot orthosis or special footwear to solve some foot problem. Now, I think the problem is there are no uniform design criteria for footwear. Different people different conditions may require different design. So some require fashion, smart, that's market driven. And some require comfort and fit. And some people say we need a shoe to protect our foot and ankle, particularly provide very stable support. But some say no, we need something to do the muscle training. We have some shock absorption function. Recently, I think the shoe become thick and thick, and most vibration or shock were absorbed. And I don't know if it's good or not. Some people say we need stable, but some shoes design like what the student present today, and try to using unstable surface. The purpose is to provide some training opportunity for those people, particularly for young person. And absorption, many shoe design try to reduce the vibration, try to reduce the impact. However, we have to go to somewhere to find a vibration machine because our bones need impact force, need vibration. I think many people work in musculoskeletal by engineering field know bone is a very special tissue. If you don't give the load, the bone will be absorbed. The strength of bone will be very reduced. So we have to give some vibration, some stimulation. However, nowadays our shoe give us a very good protection. All the vibration, or most vibration, particularly this high frequency vibration, removed. Because my team also work on high heel shoes, I will say a few words about the heel height effect. High heel shoes is good for fitness. I think a lot of reasons. Make attractive, aid height, or make the foot look smaller. I don't know why smaller attract men. And anyway, high heel shoe, and people use them. And if I take this slide, a copy from school, and we mentioned the high heel shoe will change the loading pattern for the whole musculoskeletal system, not only on foot. And the experimental show, I don't know whether the team here measured the plantar pressure with different heel height. They measured with the heel height increase from 0 to 3 inch, and peak pressure or the maximum pressure will increase by 110%, especially for the forefoot region. Okay, the pressure here will be very large. How about the shear, friction? Is another very important parameter, particularly when the person standing on an inclined surface. Frictional force, shear force is a very important parameter. And again, I think this, some slides say, the high heel shoes, if you wear too long, that cause some problem. Include problem on foot, include a problem on the spine. I cannot make sure it's true or not. I only copied these slides to say our study is important. Okay, to reduce the forefoot pressure, there are a lot of design trying to increase the loading carry for the toe region. Okay, narrow the toe box or put some force here, try to reduce the shear. Because you stand on the inclined surface and the shear will move forward, then if you can stop here, the shear will be reduced. However, our toe don't like force. Okay, we have to make sure properly distribute the force on the foot. Some regions don't like any force. Now, when we talk about the load effect or the mechanical environment of a foot on tissue, we have to understand how the mechanical load changes the tissue. So if we cut a piece of tissue here, we enlarge that, we know there are force body weight applied there, Then the supporting force can resolve to normal force and shear force in terms of this inclined surface. And those two forces may produce some bad effect on the soft tissue. So we understand soft tissue has a very complicated structure. So if we want to fully understand how biomechanical load affect our comfort, affect our tissue, we need to analyze in detail. I often use these slides to teach my students to say, if we want to understand the response of tissue to mechanical loading, we need to consider all those parameters. Because soft tissue include different layers, include blood circulation, include nerve system, and all different components. Mechanically, the so-called force include normal force, shear force in terms of skin surface. And the force can have a direction in terms of normal and shear combination. Distribution either concentrated to a small area or uniformly distributed, or duration. All those 3D affect on the tissue damage or tissue response. Now, the load can be static, can be dynamic, either cyclic loading or working, or some impact or big impact if you do some sports. Or those mechanical loading applied on the skin surface where they form the tissue. Have the first response mechanically with deformation, internal stress strain, fluid transmission, the air transport, cell contact. All those should be considered if we want to talk about how the mechanical load affect on tissue. Okay, so we have to people develop different model using the single phase, continuous, elastic, solid, or biphasic theory talk about solid plus fluid, either using viscoelastic body or probability model. And some team using triphasic theory, that means solid plus fluid plus iron, try to understanding the swelling effect. Now, the tissue damage, the comfort is one thing, tissue damage is another issue. So tissue damage can be either blister or cister or cone, most happen on foot, or the big problem is the pressure sore, maybe other part of the body. So if I summarize, the possible effect of tissue to external mechanical load can be comfort A first, blood circulation,